Good morning. My name is Sangmin. It's my honor to present our research in Code Blue. The topic of my presentation today is LG versus Samsung Smart TV, which is better tracking you. This is related to Smart TV forensic. Before started, I will introduce history of Smart TV forensics research. We mainly conduct a study on LG webOS version 3 Smart TV forensics. So we will explain analysis process in detail. What we did, what we learned, what we found. In final, we will compare our research result based on LG Smart TV to earlier studies focused on Samsung Smart TV forensic. At this part, we will explain this difference users' action in LG and Samsung Smart TV. Let me start by saying just a few words about us and my professor. First of all, as presenter of the day, I studied information security with mentor of Best of the Best in 2015. Because interested in offensive security, I mostly conducted vulnerability analysis on embedded devices. As a result, I made a presentation on POC 2015, one of the famous hacking conference in Korea, titled "What if fire sale occurs in Korea?" Now on, I'm master student in Korea University. During master course, I participated in many projects related to security testing, common criteria, and IoT devices vulnerability analysis. Next, let me introduce our second author, Min-Soo Park. Park is a PhD student at Korea University. His main research area are digital forensics, information assurance, and especially he participated in many projects related to Smart TV forensics and security evaluation. Below is our professor Seung-Ju Kim and our corresponding author of this presentation. He is interested in cryptography, information assurance, security evaluation, and certification. Now that we have finished introducing the author, we will start to announce the history of Smart TV. In the graph on the right, the share of Smart TV in the home IoT market is second only to the game console like PlayStation. Smart TV collects a variety of information from users to provide better personalized service and features in their daily lives. It is also closely related to daily life among Smart TV devices. Therefore, Smart TV has a lot of data that can track past behavior for users in the home. Through Smart TV forensics, we can get additional information that traditional computer forensics cannot get. In fact, in the US in 2016, there is a case where digital evidence obtained through Smart TV forensics is used to prosecute sex offenders. This is the first use of Smart TV for digital forensics. In order to emphasize the necessity of research on Smart TV forensics, this case is most representative. Prior to the aforementioned case, research on Smart TV forensics has been going on steadily since 2013. This picture shows you a brief history of Smart TV forensics. The first research was carried out in 2013, when Smart TV became popular. Since then, a total of 6 studies have been conducted. The same mark on the graph indicates the work performed in our lab. I will talk more about the graph in detail. Up to now, 3 studies has been conducted for Samsung Smart TV and 1 for LG Smart TV. I will tell you more in detail from the bottom of the graph. A study conducted in October 2013 and June 2014 discusses the concept of Smart TV forensics. At this time, Smart TV is starting to spread. We have many proposed the necessity of Smart TV forensics and methods of data acquisition. Then, in 2014, our lab member, Mr. Kang, performed his first practical research on Smart TV forensics. The forensic target is Samsung Smart TV. Next research was conducted on LG Smart TV and Samsung Smart TV. Through this graph, we can see that research focused only on Smart TV of a specific manufacturer, Samsung Smart TV. Let me tell you about each research from now on. This graph shows the previous slide horizontally. The first research on Smart TV forensics was carried out by author Musa. They present digital evidence that could exist on Smart TVs. And they also mentioned there are challenges that the tools used for traditional PC forensics cannot be used because Smart TV are still under development. In next, Mr. Sutherland says that the storage devices used by Smart TVs are soldered and cannot extract data in the conventional way. So we proposed 4 methods of acquiring data on Smart TV. Next is the study conducted on October 2014. This is the first practical study on Smart TV forensic. Mr. Kang used a vulnerability in the Smart TV's browser to acquire data. This vulnerability was introduced by Seungjin Lee at Black Hat USA 2013. Mr. Kang then proposed a total of 9 users' action data through the binary dipping method. Later on, our research on LG Smart TV analysis used the same analysis process. The binary dipping method will be described in detail later in our analysis. Next, Mr. Sutherland conducted another forensic study on LG Smart TV. Until that point, his Smart TV forensic study is the only one that analyzed other manufacturers. However, there are some limits that the study proceeded with failure to acquire data. Therefore, they proposed a user's action data that can be obtained from basic TV setting and application settings. User actions mean it can be used as digital evidence. Next, Mr. Bostas conducted a forensic study on Samsung Smart TV. Bostas used 3 methods to acquire data on smart TVs. Each method is eMMC, access, NFI toolkit, and using soft vulnerability. However, data acquisition using the eMMC access and NFI toolkit was failed. So they acquired administrator privilege with vulnerability acquired from Samigo. The data was obtained through this. The data analysis process is not described in their paper, but I think that used binary dipping similar to Mr. Kang's research. They proposed a total of 8 user actions data. Lastly, Mr. Park conducted research on Samsung Smart TV. This paper was accepted in November 2016, but has not yet been published. Mr. Park, who is also the second author of our presentations, conducted a study on Samsung Smart TV forensics. He compared the result with those of the existing Mr. Sutherland and Mr. Bostas' thesis. The following table summarized all of the words so far. Most notable points are followings. Only one study on LG Smart TV forensics was conducted, and the rest are Samsung Smart TV forensics. Also, study cases of LG Smart TV did not acquire the data. Therefore, we have conducted forensic research on LG Smart TV and will release it in detail. Go back to the table and look at the colored part of the table. Samsung Smart TV used a software vulnerability to acquire data. Storage in embedded devices such as smartphones are soldered. So during the forensic process, you can lose all your data through desoldering. Smart TVs also have the same problem as embedded devices. Therefore, we can see that capturing the data through the software vulnerability is possible. As we will tell you later, we also used the software vulnerability for LG Smart TV forensics. There was also research on software vulnerability in smart TVs. LG Smart TV hacking was announced by our lab member named Jungho Lee at Hacking Paris. Mr. Lee introduced a vulnerability that could lead to acquiring administrator privilege by performing vulnerability analysis on LG webOS version 3 Smart TV. We were able to identify the attack vector through the presentation to obtain the data LG Smart TV. Next is Samsung Smart TV hacking. Samsung Smart TV has the highest share in the global market. Therefore, there are a lot of research on hacking. Black Hat USA 2013 announced 2 research cases about Smart TV hacking, especially the vulnerability of the browser from the announcement of Sangmin Lee was used for data acquisition in the study of Mr. Kang's Samsung Smart TV forensics. And there is Samigo, and an online community related to Samsung Smart TV firmware. In this community, users can share firmware acquisition and analysis contents of Samsung Smart TV. Likewise, Mr. Bostach, who studied the existing Samsung Smart TV forensic, also used the vulnerability acquired from Samigo. So far, I have introduced a study on Smart TV forensic and Smart TV hacking. And there are also studies to implement secure Smart TV. In our lab, we have conducted projects referring the common criteria. Common criteria is an international security assessment standard. In 2014, Minsu Park, our lab member, announced a study on the development of the protection profile, which specifies the minimum security functions Smart TV should have in ICCC. In this year, Su-young participated in the study on CC Common Criteria certification of LG Smart TV. She was the first to obtain a CCEAL2 certificate for LG Smart TV and published it as a thesis. Left side, this is the CCEAL2 certificate of LG Smart TV. This certificate acquired through the research project in the lab. Currently, LG Smart TV has acquired the CCEAL2 certificate, and Samsung Smart TV has the CCEAL1 certificate. So far, I have put all researches on forensics, hackings, and security evaluation of Smart TV together. In conclusion, we can see that the research on Smart TV is carried out in various ways. We also found that in the case of Smart TV digital forensics, there is a limit to the fact that research is focused on specific manufacturers. Besides, one study on LG Smart TV forensics shows that the data was not acquired. Therefore, we conducted research on LG Smart TV forensics. Now, let me talk about what we have done for LG Smart TV. We will talk about data acquisition process in detail, and we will talk about the data analysis and collection process. The analysis target is LG webOS version 3 Smart TV. The firmware version is 4.13.85 and it was the latest version at that time. But currently, it was updated again on October 28th in 2017. LG Smart TV uses webOS. webOS is a Linux kernel-based mobile operating system that is used by various LG products. Various embedded products using webOS is introduced at CES every year. This year, LG introduced a refrigerator using webOS. I'll briefly finish the introduction part, and from now on, let me talk about the process of data acquisition. First, there is invasive physical data acquisition. However, smart TVs have soldered storage devices. Furthermore, debugging ports such as JTAG and UART are also disabled. Desoldering soldered storage is laborious work. If desoldering works go to fail, you should have risk for taking the risk of failure in smart TV. Currently, our TV is about $1,000, so it is very expensive price for me. Of course, Mr. Bostas, our researcher on Samsung Smart TV forensics, mentioned it has the disadvantage of using application vulnerability that can easily be blocked by firmware update. In contrast, the physical method is difficult, but once you have succeeded, you have the advantage of continuing to use it. But in order to collect the LG Smart TV's digital evidences, we need to see the data multiple times. So we have acquired data through application vulnerability for data acquisition. There are two ways to obtain data using application vulnerabilities. One is a way to exploit the zero-day vulnerability, the unknown vulnerability. There is a way to find a zero-day vulnerability directly, or if you can purchase the vulnerability, you can purchase it. The other one is a way to exploit one-day vulnerability. One-day vulnerability can use exploit code published in CVE or exploit database. You can also identify attack vectors through material published at hacking conferences such as Black Hat and Hack in Paris. Through many conference papers and vulnerability database, we can personally analyze the one-day vulnerability. We decided to analyze the vulnerability directly to acquire data from LG Smart TV. We saw the announcement of Hack in Paris and identified the attack vector. The attack vector is a webOS emulator that is distributed to developers. The emulator has many features such as enabling SSH service on your TV, installing and running apps remotely on your TV. So we analyzed the emulator intensively and found a command injection vulnerability that could again administrator privileges. I prepared the video, but I explained the vulnerability in detail, so I will explain by the picture. If you access SSH through emulator, connect as prisoner account. However, the account cannot access all file systems. At the bottom of the picture, you can see that the result of the mount command is 0. As a result, we have found a vulnerability in command injection that can elevate privilege through analysis of the emulator. So I got root privilege as the command injection vulnerability, and I was able to access all the file systems. You can see that 115 results are printed by executing the mount command. Of course, this vulnerability has already been patched via a firmware update. There is a point to be noted before going forward. How can achieve the integrity of original data when data is acquired by routing? Take the digital forensics of smart TVs as example. Smartphone as example. Smartphones are clearly divided according to the use of partitions. Therefore, there are partitions affected by the vulnerability. The partitions cannot preserve integrity. Therefore, the data on that partition is not recognized as digital evidence. In contrast, partitions that are not affected by the vulnerability are not compromised. The data on that partition can be used as digital evidence. In the case of smart TVs at present, the partitions are not clearly divided, so many partitions are affected by the vulnerability. If the integrity of the data is taken into consideration, integrity can be preserved on a folder-by-folder basis. In my opinion, as in the case of the United States, there will be a social debate on using a vulnerability to acquire original data against smart TV as the need for smart TV forensics increases. We acquired data through software vulnerability that exists in the webOS emulator. Next, I will explain the process of analyzing the data acquired. We already acquired root privilege, and now it's time to analyze the data to collect the user's action data. The first thing, we checked the file system using mount command on Linux. A lot of mount information was displayed through mount instruction and a mount command, and I checked the mount information of the flash memory starting with mmcblk. mmcblk is a block of multimedia card, which is the memory card standard of flash memory. In the table, there are partition blocks from mmcblk 15 to 52. As you will see on the next slide, however, mmc block mount disks do not change as you use your TV except 15, 51, and 52. Therefore, we focused on mmc block 15, 51, 52, where data is created, deleted, and modified according to TV usage. Next, let's talk about the data analysis process. The process totally takes 6 steps. First step is data acquisition and file system analysis. We used application vulnerability to gain administrative privileges and obtain data. We also identified the MMC block partition through file system analysis. Second step is the pre-imaging. Through the dd command on Linux to image or MMC block partitions. Third step is just to use the functions of the TV, such as application launch, HDMI connection, or some other things. Fourth is post-imaging step. Through the dd command, imaging all the MMC block partitions one more time. In fifth step, we compares the data between pre-imaging and post-imaging. We did binary imaging using the diff command on Linux, WinHex, and Beyond Compare on Windows tool. This allows us to identify users' actions data that can be used as digital evidence. Finally, repeat steps 2 and 5 to identify users' action data that can be used as digital evidence for various functions on the TV. The environment I implemented to perform steps 2 and 4 of the process is shown below. It takes about 10 minutes to imaging or MMC block once. Therefore, the most important thing to consider when imaging a disk was to minimize storage space and minor mistake. My target is using a small amount of flash memory, so this can cause problems during the imaging process. Since the TV supported USB, I saved the image file to USB. We also used the TFTP on Linux to transfer the image directly from Smart TV to computer conducted analysis and immediately delete image to minimize any human error due to the increased image file. Smart TV provided Python, so I wrote a script and got it to work at once. Of course, the reason I used Python script was to minimize mistakes. The data analysis process described in the previous 5 steps will be explained again with an example. Steps 2, 3, and 4 of the analysis procedure is like this slide. In step 2, pre-imaging is conducted. In step 3, just use the TV features such as TV on/off and HDMI connection. In step 4, post-imaging is conducted. In step 5, through comparison between the pre-imaging file and the post-imaging file, we find the user actions data. Mount each imaged file in a different folder. Then run pre- and post-image diffing through Linux diff command. If you execute the whole pre- and post-image file through the diff command, you can get the same result as the picture above. From the result, You can identify the data from create, delete, and modified in pre and post images. After executing diff command with -R and D option, you can see which files are created or deleted. If the different file is plain text files, you can see the contents through the diff command. Also, if the different files type is binary, you can identify the binary file are different. After this, binary files marked differently were analyzed manually by beyond compare and WinHex file one by one. So in the case of a binary file marked different from the result obtained by the diff command, binary dipping was conducted in Windows. It took a long time to go through the manual. Through the analysis process, various users' action data that can be used as digital evidence are identified. Let me talk about this. We have identified 12 users' action data that can be used with digital evidence through our analysis process. For each user actions data, we will explain it in comparison with the results of previous Samsung Smart TV forensics research. However, 3 marked users action data have a special character that data is volatile. So only the 3 will be described in detail. First, let me talk about last TV on time users action data. When you turn on Smart TV, the TV turns on first and webOS boots in the background. A log file including last TV on time information is created each time when webOS is booted. Then let's take a look at the picture below. The contents of the log file could not check correctly. I carefully guess it is related to booting, but the information marked by the red rectangle always pointed to boot time. Therefore, although it does not explicitly indicate last TV on time user actions data, you can obtain last TV on time information by viewing the data and time information in the log file. The following is about users' action in external storage history and recently service usage history. Two pieces of information share a single log file. The log file has a .log extension, and file expressed with asterisk is given a certain number every time the TV is booted, but I have not found a reason why this happened. The asterisk.log file also use their own format, so we continue to analyze the format, but we could not figure it out. The exact format is unknown, but the file's content exists in the plain text. So I could manually analyze it through the text viewer. Let's move on to user actions again. First, let's start with external storage history. LG Smart TV offers a USB port for photo, video, music, and patch functions. When the storage device is connected to the corresponding port, the serial number of the connected device and the file name information existing in the connected device are stored in the log file. In case of serial number, it is displayed as hexadecimal value. You can check the serial number by converting hex value to ASCII code through script. The bottom right photo shows the serial number of the same storage device connected to my MacBook. You can also see that log file record the file names that exist in the connected external storage device. However, there are also unknown strings in the log file. I continued to analyze, but I could not figure it out. Next is the recent service usage history. It is stored in the same file where the previous external storage history stored. The log file writes new data by appending them at the bottom. When you run the application's package name is written to the asterisk.log file. Therefore, you can check the log file to find out the order in which the application runs. However, the three user actions mentioned so far are characterized by being deleted each time the TV is turned off and usually created when turned on, which means it is volatile information. So far, we have introduced the result of LG Smart TV forensics. Finally, let me tell you a comparison of digital evidence presented in a study on LG and Samsung Smart TV forensics. The comparison results are shown in the table. The comparison with LG Smart TV is Sutherland's research, and the comparison for Samsung Smart TV is research on Mr. Kang and Mr. Boztas. First, our research and Mr. Sutherland analyzed smart TVs with webOS version 3 and version 2 respectively. And we used software vulnerability for data acquisition. However, Mr. Sutherland proposed only a simple user's action that could be checked in the configuration because the data acquisition in his research was not successful. So we compared the forensic research except for the Mr. Sutherland's. Mr. Kang and Boztas on Samsung Smart TV analyzed Smart TV with proprietary OS. For Samsung Smart TV, they currently use Tizen, but there is no research on Smart TV forensics that currently use Tizen. We think that forensic research is necessary for Samsung Smart TV using Tizen OS. In the data acquisition procedure, all three studies used software vulnerability. In the data analysis procedure, our research and Mr. Kang's research performed binary dipping after partition imaging. In case of Mr. Boztas, he did not mention in detail on the data analysis procedure in his paper, but I guess he used the same method. And to conclude, To conclude, the table shows that you have used software vulnerability to acquire data on embedded devices. Therefore, the existing software vulnerability, such as digital forensics of smartphones, is likely to become an important issue for smart TV forensics. Now let's compare each study's results. O mark in the table means discover the user actions on the TV. In the contrast, X means not discover user actions data or not exist on the TV. First, it is user actions data on the TV's traditional function. In case of last TV on time users action data, it was existed in LG Smart TV and Samsung Smart TV analyzed by Mr. Kang. As I mentioned before, LG Smart TV acquired last TV on time data from the log file. On the other hand, Mr. Kang's data is directly known by month and day. However, the year information should also be implicitly checked by other files. Also, TV channel list and external storage usage history user section data are found in both LG and Samsung Smart TV. The TV channel list data is the same in all studies. The storage format is SQLite or binary. In case of external storage usage history, Samsung Smart TV records only the model name of the external storage device in SQLite format, and that TV file remains on TV boot. LG Smart TV, on the other hand, stores the serial number of the external storage device and also stores a list of internal files. However, as mentioned earlier, the log file is initialized when the TV is booted. Next is user actions for smart TV applications. You can see that installed app information, internet history, and recently service usage history data exist. However, checking captured image exists only on LG Smart TV. Because Samsung Smart TV analyzed by Mr. Kang and Mr. Bostas has no capture function. The installed app information data typically contains the package name, app ID, installed time, and app version. And in the case of internal history data, it is the same data that can be obtained from general PC forensics, such as visited URLs and favorite sites. And in the case of internet history data, it is the same data that can be obtained from general PC forensics, such as However, Samsung Smart TV has the feature to store up to the number of visits, like this. As mentioned before, LG Smart TV's recently service usage history data is recorded in the *log file of application execution order. However, the log file is initialized when the TV is booted. Samsung Smart TV does not have a picture, so I will explain it in words. Mr. Kang's TV stored the file name of the recently played video, the name of the executed the application and visited URL in a specific file. Each data is not always saved, only the last three. Mr. Bosta's TV stored the path of the application icon that it launched to a specific file in order. We can see the recently service usage history data from this file. Next is the user actions for system configuration. Connected Wi-Fi information data exists on TV analyzed by Mr. Bostas and our research. I think we can check this data from the TV setting through the remote controller. Mr. Kang did not suggest. I think it will exist every smart TV. In case of TV analyzed by Mr. Bostas, we can see very general network information. But in case of LG Smart TV, you can get more detailed data about Wi-Fi information. In case of LG Smart TV, general information can be found in network settings. However, internal stored data contains more information. This picture shows the information of the device connected to the TV. Finally, it is users' actions that are unique to each smart TV. Users' actions written in the table can be directly found depending on the manufacturer's implementation method or physical characteristics. First, let's take an example of the difference in implementation method. For example, in case of TV on and off, TV on-off reservation, Samsung Smart TV does not have TV on-off reservation function. Additionally, request information in the cloud application users action data exists only in Mr. Bostas TV. And let me give an example of the difference by physical characteristics. For example, in case of camera usage, LG Smart TV does not have a camera. The user's action that we describe now is affected by the implementation method or physical characteristics, so it is likely to be different for each manufacturer or product. Initially, I have talked about related research on forensics, hacking, and security assessment for smart TV. And I described the research on LG Smart TV forensics. I'll talk about my personal thoughts about the integrity of smart TV data when acquiring data using software vulnerability. Finally, we compared the result among LG Smart TV and Samsung Smart TV forensic research. Now, let me tell you the conclusion of today's presentation. We acquired the data by gaining root privilege through software vulnerabilities. We analyzed the data through pre-imaging, testing, and post-imaging processes, and proposed a total of 12 user actions. Our suggested user actions are 5 for TV's native functionality, 5 for the pre-installed applications, and 1 for the system configuration. And we compared LG and Samsung Smart TV. As a result, we found when conducting smart TV forensics using software vulnerability for data acquisition is in common. And Large classification of user actions proposed in each study was found to be the same, but depths were different depending on implementation method and physical characteristics. Although the depth is different, I think that the user's action that each TV has in common can be utilized as main digital evidence when performing actual smart TV forensics. I also think we can use the unique digital evidences of TV by analyzing the characteristics of a smart TV first. Thank you for listening. This is the end of my presentation. If you have a question, ask me without hesitation.